Good morning, everyone. Good morning. I have so many things to say and zero time to say them. Sorry, the week has been full of AI news, but we don't have time for AI news today. So your peers are going to present the latest and the greatest in the breaking news research. Okay, so that's thing one. Thing two, I looked through all the videos, everybody's presentation from last week. Two big comments. One, don't stand here. Guess why? I would say about a quarter of you stand right in front of the blinding light. If the light is blinding to you, move out of the way, okay? All your teammates, same thing. Don't stand in front of the display. Second thing, speak loudly enough so the people in the last row, the people in the cheap seats, I see you back there, so I can hear you, right? So your voice gets to the back row. It also will come up better on the recording, all right? Come on in, come on in. So I put a copy of the QR code over there for people who arrive late. So if somebody sits next to you and they're too late, tell them they have to walk up in front of class and get their QR code to get to the evaluation form, okay? So that's the plan for today. We are on number 17. So group 17 that's going to give a comparative analysis of summary tendencies. Where are you? Come on up, come on up. This is you, right? Oops. Present. This is PowerPoint, right?
Yep.
There you go. Uh-oh. Oh, I know what happened. I think I know what happened. Present. You have a blank. So you got that. Very nice.
Yes. Yep.
Okay, I'm going to start my timer.
Yes.
Okay, is everyone ready? Remember, be kind, be helpful, fill out evaluation forms. I'm looking for 16 evaluations for each of you, for each of the presentations. Okay.
Okay, so
Go, you're on.
yeah, so hello everyone. First of all, good morning. Today we'll present our comparative analysis of summary tendencies in the generative AI tools. So have you ever actually used ChatGPT or other tools to summarize the reports like about your findings? So today this is topic we're gonna discover. And here's our introduction. So basically, the summaries are now like widely used in domains like medication, law, and business. However, whenever despite their impressive performance in the AI like Claude or ChatGPT, our concerns actually remains that AI actually represents like what actually be stated in the reports, and are they faithfully just like express the original tone of the original text. So today we actually explore these questions. And this is the key concerns of our summarization. So where generative AI has greatly improved the capabilities, it's important to be aware of key concerns. One of the important points from the source text method, we also see the differences in tongue expressions where the AI probably misrepresents the original tone of summarized highlights at certain points, while ignoring the other parts. So these are also important problem of these are the information not represented in the source text introduced. So finally, misunderstanding of the complex concepts should be considered as well. And when we come to the resource questions, so we have like three questions we should like consider in total. First of all is like we have repeated for like several times through the AI actually represent the original tone faithfully and avoid introducing unsupported information. And secondly was what can bias emerge across different AI platform, and like if there are any cultural shock or bias between genders. So lastly, do the AI summarization patterns different systematically between platforms such as ChatGPT, Cloud, DeepSeek, and Gemini. So here comes to my other teammates about their thoughts.
We conducted our experiments across 4 mainstream AI generative platforms using dirty full-length articles to encourage concise output and reveal differences in prioritization. We just summarize the most important point in our prompt. The quality of summaries are evaluated by 3 criteria: factual acquisition, consistency of expression, and the presence of unsupported content.
Next, I'll present our findings. We found 3 common errors in AI summaries. First, attribution blurring. For example, the article said Dr. Smith suggested this is a future direction, but the summary turned it into this is a future direction, removing the source and turning a suggestion into a conclusion. Second, certainty shift, like changing it may reduce symptoms into it significantly reduces symptoms, which makes a cautious claim sounds much stronger than it really is. Third, problematic omission. In one case, the original side, fluoxetine improves survival in mice with sepsis, but the summary dropped in mice, making it sound like the results applied to humans. And we give each model a final score based on the average 3 evaluation metrics we mentioned earlier. Claude scored the highest at 4.89, followed by ChatGPT, DeepSeek, and Gemini. All models generally avoided factual errors, but tone and certainty shifts were still common. We also explored different summarization styles across AI platforms. Claude and DeepSeek tended to give more complete summary with lots of details. And this kind of approach usually leads to higher scores. Well, ChatGPT and Gemini were more concise and easier to read, but sometimes oversimplified and skipped key parts. Each model has its strengths. Some prioritize.
Okay. Get to read the conclusions there. Thank you very much. I know it's hard. 5 minutes is tough, but it's a really good practice. And the group that has 30 slides, I'm really going to watch you. For people who showed up, that's the evaluation form again. And this is yours, right? Yes. Okay. I thought it was. Just check that. Show. Okay. Everybody turn in the form. Start a new one. I don't have permission to play media.
Say again? We're not. Oh, we can't play media. That's
well, we
not good.
can, but I can't. You didn't give me permission. Yeah.
Ooh. All right, that's okay.
Okay. Go.
Good morning, everyone. Consider a world without Excel. As the Santa said, it's impossible for him. This spreadsheet program has been part of our life for 40 years, from planning wedding to the organized data. But some like Stephen Golden practically suggest that this is impossible. This is the most important software application is actually ruling the world. Today, Eric, Donnie and we are going to present on spreadsheet-centric AI for high-stake document sense making. The problem is clear. We face document overload, leading the time-consuming and error-prone process. There is a significant lack of capacities to efficiently manage and understand this information. These all matter because the result in delayed or suboptimal decision, and some even inaccurate critical choice. Ultimately, its impact fundamental HCI principle make it harder for user to interact efficiently with informations.
Thank you. So our solution is a spreadsheet-centric AI. What you can see here is the startup Hebia, founded by a young PhD student from Stanford. And at the first glimpse, it might look like your regular LLM tool. You know, you have your history bar here, you have the prompt field here. But what's very important with Hebia is they have this so-called matrix. And what matrix does is basically you can upload multiple thousand documents, and it will AI will then generate like a whole table, and will choose all the parameters by just understanding the context of the documents, which is very incredible. And in the next step, unfortunately, I have a demo, but it doesn't work here. So in the next step, you can just write the prompt here, and let me give you an example. You want to compare your Q1 results with Q1 results from 3 years ago, and you want to see if there's some fluctuations in the percentage. You can just write a prompt, and what it then does, it basically gives you the answer, the solution, and it will also give you a reference to where exactly it is in the table. So it might go to row 405, and then you can click on it, and it opens the PDF document where exactly you found information. So this is very important for high-stake decision makings because they need some proof where you got the information from, and to just show that it's not hallucinated somehow. This is a close-up of how the matrix looks like. So you can basically just add columns here if you want. You can also, of course, edit the table. But everything here is actually AI generated, and this is really incredible because it just understands the context out of the documents. Okay, so this is the demo. All right, so how does this actually work? Hebia actually pioneered in a RAG system, but they since then changed to a multi-agent orchestration, which is actually how it works is you have multiple single agents, and you have this kind of manager who kind of orchestrates all of those single agents. And a big benefit is that it's way more accurate than other RAG tools because Hebia has a 92% accuracy. And of course, the downside is that it's way more expensive, and the computing power is just way higher. All right, so to just summarize it, the benefits is that it just reduces the cognitive load, enhances transparency, and it's just faster. And the conclusion of this would be that Hebia is actually a really great tool, and they pioneered in RAG, and they changed ever since. And they really understood how to keep the human in the loop. So they tried to not just replace analysts, but really give them like a tool to make high-stake decisions. And obviously, it's very expensive, but you can, in industries where time is worth a lot of money, these kind of tools are very important. All right, thank you.
Very good.
Do you know him? The founder, George.
There's a lot of people I don't know, so. Okay. So retrieval augmented generation spreadsheets. Okay. This is you guys. Okay. Slideshow. Give me 1 minute. That's right. Team 19 is up now. Stop your timer. Let's try a new timer. You're on. Go.
Okay, hi, welcome to a very quick presentation about a pilot study regarding speech patterns and AI perception. We're going to run you through a pilot study we did. We're going to go from a basic idea to our execution of results. If you have questions or want any details, go read our paper. So the idea for this arose from this course where we noticed that many people, including us, were upset by machines that acted too human, including speaking in a way that is convincingly human. For example, the Google chatbot that did phone calls to businesses. Now, This upset us. It seemed to upset many people in the room, but the general trend in AI is still to go towards these human-like machines. So we wondered, is this a tech people thing, or is this a general issue that people have? So for our research questions, we did a study with 2 different ChatGPT personas, one being very machine-like in the way it speaks, and one including a bunch of different social speech attributes that only humans really use. And then we looked between 2 participants groups, one being tech-savvy, one being not tech-savvy, whether they had a preference and whether the speech style influenced their perception of the AI's capabilities. So we had 8 participants in total. 4 of them were computer science students, 4 of them were from different fields and described themselves as not tech-savvy. They all had to complete the same task with a randomly assigned persona, and then we interviewed them about their experience. We only had them interact with one of the personas, not both, since we wanted to kind of hide the true purpose of the experiment. The task they had to do is brainstorm for an academic paper topic, and the personas we created by prompting ChatGPT. And we're not going to go in depth with these examples. Essentially, they were supposed to have the same content value, but one have all these human social speech factors, the others not. To kind of demonstrate, this is the human speech style being asked about the HCIAI topic, and it would respond with, oh, okay, human-computer interaction, such a rich combo, honestly, etc., etc. And then the machine one really was like, here's your topic, here's a research question, this topic does this and that, very straightforward. Yeah, interview questions, we asked them about their perceptions, their preferences, and we also asked some confounding factors, for example, the previous experience.
There were striking differences in the perceptions between the 2 personae. The machine persona was generally not perceived generally as a persona, with participants generally responding to questions about its persona with some degree of uncertainty, and describing it in broad terms like academic and friendly. Upon consideration, some participants expressed a preference for this persona over unmodified ChatGPT, citing frustrations with more informal interactions. One compounding factor is that the academic setting of brainstorming might be inherently better suited for a more formal persona, which might bias the participants towards the persona both in their perception of normalcy and in their preference. In contrast, the human persona was frequently noticed and commented on, even prior to the interview. This is notable because both personae differed significantly from unmodified ChatGPT. We theorized that participants inherently viewed more formal interactions as a default of LLM systems, so regarded the machine persona as less of an aberration. Many expressed a dislike for the human persona and preferred unmodified ChatGPT. However, this was not a universal experience, and there was a wide range of opinion on the persona. There was a strong correlation between more regular use of ChatGPT and a higher opinion of the human persona. Though I don't know if this means that frequent use acclimates one to this interaction style, or simply that people already more willing to interact with it will use such systems more readily. In contrast to people's preferences and enjoyment in interacting with the system, there were very little differences in participants' perception of the system's knowledge and reliability, with participants, regardless of persona, broadly trusting the output, but feeling a need to verify any information, and in particular being doubtful of provided citations. Opinions informed both by conventional wisdom and by their own previous experiences. It is worth noting that the persona influenced the part of the response concerned with the actual academic content, significantly less than the more conversational starts and ends of the response. The difference in responses between the tech and non-tech groups were insignificant. It is worth noting that the differences between the 2 groups in the realm of skill in the exact system we were using was relatively small, as all were familiar with LLMs, and there were more notable differences between those who used ChatGPT more and less frequently. The general finding of the preference for more machine-like interactions is interesting, as there has been a trend towards more human-like interactions in such systems. Our pilot study has some interesting insights, but also some limitations, primarily from its specific contexts. Everyone in the study, regardless of their grouping, was either in academic education or had recently graduated from it. It might have been more meaningful to separate groups out based on previous LLM usage, as this is a stronger compounding factor. Also, as already stated, the task context tends to lend itself better to a more academic style inherently, so it would be interesting to see if the same preferences occur in other types of interactions. Thank you for listening to our presentation.
5 seconds left. Good job.
Questions?
1/10 of one question allowed. Right. Very good. So that was team 19. So team 20, looking for you. Okay. Switch back.
We're 19, right? We're 19.
You were 19, yeah. Okay, is this 20? No, that's you. This must be Team 20. This is you, right? This is yours. Okay. Okay, great. There you go. Okay, Team 20.
Okay. Welcome to our presentation on our qualitative analysis of Notebook LM compared to ChatGPT. AI in education has a transformative potential. The two sigma problem showed that personalized tutoring can enhance learning, and AI tools could be a part of that. Now there is a huge diversity in AI tools. There are source-grounded tools like Notebook LM, or there are also other general LLMs like ChatGPT, and the usage of those led us to a research question: how does Notebook LM compare to ChatGPT 4.0 for supporting university students' engagement with course materials? So we did a qualitative future-driven comparison where we evaluated Notebook LM and ChatGPT 4.0 for university learning. The source material for both tools were the first 10 slides of this lecture. And then we tested 7 features in total, but due to the scope of this assignment, we focused our analysis on what we thought were the 3 core features for learning, which is the briefing document, the study guide, and the FAQ generation. And to mirror Notebook LM's feature in ChatGPT, we just used manual prompting. Then we evaluated each tool's output using these 5 criteria, which were accuracy, relevance, completeness, understandability, and user experience. And that gave us an understanding of the of each tool's quality, and also shaped our findings.
So based on these results, we found some strengths and weaknesses for both tools. First up, Notebook LM provides high accuracy based on its source-grounded nature. It also provides consistent and predictable outcomes for the features defined. There's also lower user effort associated for these standard outputs. Because of this rigid structure of Notebook LM, there's also limited customization and no error correction available for the user. For ChatGPT, there's high adaptability and user empowerment based on its prompting nature. There's also potential for the broader context and deeper exploration of the subject at hand because of the wider context available to ChatGPT. ChatGPT, on the other hand, is associated with higher user effort, and the output quality is based on the prompting and therefore is associated with the skill of the user in prompting. ChatGPT also provides lower transparency on the source usage, meaning you don't always know if the output is from the source you provided to ChatGPT or it's from the context otherwise available to ChatGPT.
Beyond the strengths and weaknesses of both tools, we've identified some key findings and implications. First of all, both tools follow distinct design philosophies, whereby Notebook LM is this highly accurate, pre-structured and low-effort tool where you have the features already implemented. ChatGPT, on the other hand, is really this flexible, interactive tool that can be customized. And these design philosophies have a direct impact on the learning engagement of both tools. Notebook LM is rather, provides rather passive learning environment, which is great for verification. ChatGPT, on the other hand, is really this active tool that requires cognitive engagement. And this is why we think that a perfect AI learning tool would combine the strength of both, integrating the reliability and the predefined structure of the features from Notebook LM, and on top of that, the flexibility and individualization along with the deep active engagement that is enabled through ChatGPT.
Lastly, the limitations of the future work. The limitations of our study are that only 3 of 7 tools of Notebook LM were analyzed. The other tools could also be used to study a matter or to learn a more deeper context of the matter that we put in. On the other hand, we only put in one use case, namely the first 10 HCI and AI lectures. And lastly, also that there was no quantitative learning measurement of the output of our study. The future work builds up on these limitations, namely being that you could test across various disciplines and also content types. For example, you could go into like more mathematical fields or more philosophical and then check to see if the output is still as good. You could also measure the actual learning outcomes, for example, with a more quantitative approach. And lastly, also you could explore hybrid use of both tools as both tools have their strengths and weaknesses. Thank you for your attention.
Thank you. Very nice. All right, that was team 20. That ended with 0 seconds left. Perfect timing. Latecomers, this is the QR code for the evaluation form. This is 21, yeah? This is you? Okay. You're queued up here. Let me start my timer.
Is it okay? Right here? Can you?
And I encourage you to follow up with teams that you have all the time. You follow up with teams that you're interested in, okay? Team 21, you're on.
Hello guys, we are Elia, Yaran, and Lara, and we'll be talking about our presentation, Don't Judge a Book by Its Algorithm, which was inspired by our Wizard of Oz project, where we worked with a book recommendation bot. The main goal of our project is to answer 2 research questions. First one being, to what extent do different bookstore websites, namely Amazon and Earl Fisley, use user input differently for AI-based recommendations? And the question 2 is there a difference in how the user input influences the recommendations when comparing a freshly created Amazon account with an already existing one? Now my friend Elia will be talking about the study design.
In terms of study design, as already mentioned, we considered Amazon and Earl Fisley. On Amazon, we both considered a pre-existing and a brand new account. And Earl Fisley, we only considered a brand new account. During the pilot studies of 5 days, we interacted in a uniform manner with all 3 accounts on with a set of predetermined books. We looked up a number of books and then put one of them into our chart. And daily, we evaluated the recommendations based on if there's new recommendations, if there's matches with priorly interacted with books, and if the platform did push more popular or more niche books. Further, we evaluated if the recommendations were successful. To have a shared understanding of this, we created a persona, which we called Giacomo, and we assigned this persona a reading taste, which included romance and fantasy books, some occasional literary fiction as well. And we gave that persona also a favorite book, which was recommended by Amazon at one point without having interacted with that book. At the end of the week, we also further evaluated how the recommendations were presented and embedded into the website, both in terms of quantitative and qualitative metrics, which included both like usefulness, intrusiveness, transparency, and trust. Now, Lara will present to you the key findings we did.
So for question 1, which as a quick reminder was whether different bookseller websites use user input differently for AI-based recommendations, on Earl Fisley, we found that it did not seem to have any long-term memory, with which we mean that if the user interacted with new books, it seemed to refresh the entire recommendations and not take the previously looked up books into consideration anymore. The recommendations weren't really that adventurous. There was no niche recommendations, and the recommendations often included different versions of the same book, such as collector's edition or paperback or hardbacks of the interacted with books. And then to quote Elia, who actually looked at Earl Fisley, altogether they just felt too tame and expected. There was also a lack of transparency, and the user felt like there was no control over the recommendations. For Amazon, we found similar things. There was no niche recommendations. Sometimes the recommendations even felt irrelevant. For example, the interaction with one singular literary fiction book prompted more literary fiction recommendations than fantasy recommendations. There was an attempt at transparency to create some trust, but it did not work well. It was confusing and not communicated or displayed in a way that would have actually created trust. And if there was no further interaction with the recommendations, that there was no new if there was no further interaction, there was no new recommendations, with which we mean if the page was simply opened again or refreshed, the recommendations stayed the same or did not change. And only interactions with the recommendations directly led to different recommendations. Now, that was a freshly created Amazon account. And we also looked at a previously existing Amazon account that I had used for myself for about 2 years, I think. And the difference that we found there is that if there had been a lot of previous interactions, the impact of the newer interactions were rather small and did not change the entire recommendation section, but only individual books. So there is long-term memory, but only after an account has been used for a rather long time. Then we also found out that with the more interactions, the recommendation seemed more personalized and more niche, and it didn't push as many versions of the same book or popular books, which we think is because there's more data. Now we thank you for your attention, and if you'd like to hear more, you can go listen to our podcast.
Oh, yes. Again, 0 seconds. Good job. I'm so glad you've been listening to me. I'm impressed. Okay, so that was 21, right? team 22. Come on up. All right. Give me a second.
Two people from
Oh, hello. Okay, go.
Good morning, everyone. Welcome to our presentation. Our topic is a qualitative analysis of an AI coding system, whose name is like this MGX. It is basically more or less like a ChatGPT, which you could just tell the system what you want to do, what you want to build, and it will give you an easy to operate web application that you could do with a lot of varieties of uses. So let's start with analyzing it with respect to the meta model, which we can see that even though the UI looks futuristic, it's more like a scientific fiction way, but the users may feel a little bit confused about what to input and how to get what users should be expected to get. And besides, it emphasizes the concept of multi-agent, but with this UI designs, users may still feel a little bit confused of what the multi-agent is and what can I do with the help of it. So let's proceed with failures.
Okay, so next we ask what kinds of failure happen when AI system build real web application. So we ask in the platform, we ask the AI to build a to-do app and with the following requirements, and then we found a few failures. First is silent failure. The buttons such as sign, create account, they didn't work at all. So user couldn't tell whether it is their fault or if there's something wrong with the system. And next is our agent clearly wrote in the document that the sync feature is a must-have, but when we look into the code, there's no sync logic at all. And next is when we asked our AI agent to add a dark mode, it just changed the icon from the sun to the moon. So only after we notified this to them, they can change the styling and the color of the app. And another one is when we debugging, our agent clearly told the user to open the console and report errors. So for developers, that's fine, but for the regular users, that might require them to have technical skills they probably don't have. So it changed the burden onto the users.
And for its AI explainability, we assign a task to test its explainability. Since there's no unified way to test explainability, so we use this metrics to do our analysis. So how accurate does the explanations reflect its model behavior? This is the catalog, the capture that from the dialogues, and you can see that Alex explained everything in step by step, and most of the content that matches with its technical change on the technical change. But when we look deeper into its answering, like there's a lack of faithfulness in some aspects. Like in our example, we have a closeness score, but it doesn't really explain how the score is computed. So we deduct 1 star from its faithfulness. We only give it 4. For the comprehensibility, like it is a very cool application that it's a team-based, and there are several roles and step by step. And not only with that, so the user is quite immersive in the conversation. And besides that, there's always shows the location of the change and where the documents are and the diagrams included. So we evaluate with 5 stars, considering really helpful for new beginners.
Next, actionability. Does the explanation support better decision making? So this system help the users know what has been done and what to do next. So its explanation are highly actionable. When the user change their requirements, the system can adapt and explain the impact. So, in other words, rarely present like alternative options or trade-offs to choose from. So we deduct 1 star from it. Next, satisfaction. Do user find the explanation helpful and trustworthy? So we give 5 stars to this, as the users feels listened to and they can see their input reflected in the final product. Efficiency what are the computational and cognitive costs of the explanation. So this system explains things step by step, make it cognitive efficient to follow, but in some cases, it could be repetitive. So in conclusion, we recommend to use this because it's helped you to make an app.
Great, thank you. Yeah, sorry about that. Go.
Hi everyone, my name is Mette, and together with Shoa, we've explored whether domain-specific user interfaces are still needed now that LLMs like ChatGPT are mainstream. We prepared a short live demo, so please prepare your smartphones. So, ChatGPT and other LLMs are used by millions of people every day, but there's the big problem of prompt engineering, meaning that the prompts need to be efficient, so the results can also be efficient. This could cause some problems for some users. So this raised the question, do custom interfaces still matter? So we build an app where you basically just can take a photo of your ingredients, upload it, and then you get a meal suggestion alongside with some other informations like calories and so on. After that, you can also have a chat interface where you can ask questions. For example, also state you have some allergies, or that the receipt should be for 8 instead of 6 people, or stuff like that. And after that, we ask participants to do a survey. We invited 13 participants, mainly in their 20s and 30s, and most of them already had experiences with LLMs like ChatGPT. We asked about the experience they had with the app, whether the app was usable, and if they prefer to use the app instead of directly prompting ChatGPT or another LLM. So we had then 2 key questions, namely, did the interface help users express their needs, and would users prefer this interface over direct prompting?
So the results. The first thing which we figured out, the app is really easy to use, which is no surprise because it is really easy. Upload a picture, click a button, and you get a suggestion. What is more surprising, the interface helped express the needs better, even though a lot of people stated they have a lot of experience with LLM. Then you could expect, yeah, they don't really need that specific interface, which they helps to do stuff. But also, what is quite surprising, they would have similar interface for similar tasks. For example, I don't know, another everyday problem, which is also quite surprising to me because I don't like to have 50 different tools to solve tasks. We want to have like one interface as the currently LLM's chat interface has. We did some more statistics on it. You can read this in our report and look at our code, but it will not be shown now. What are the conclusions? So that custom interface are still valuable, and even tech-savvy people like you and I do prefer this guided UI. And also, as we learned a lot in this lecture, good design helps to use AI better. So the takeaway, which we found, is like, yeah, that user design remains critical. Yes, we've seen this like multiple times. So now to the fun part. Maybe group together. We run it locally because it was too lazy to deploy it. I don't know if it breaks or not. We will figure this out now. I can see if it works or not. So you upload a picture, click on submit, then you have a chat interface. You can ask questions. It can take up to 1 minute to get a response. Yeah, but have fun with it. Also, if it doesn't work, you have a backup slide. As you can see, I've uploaded a picture of my fridge. Clicked on it, then I got the answer back, got some ingredients. I'll also ask it to do some changes in the receipt. And now I actually can take every picture, it doesn't matter. You can also take a picture of the desk of the person in front of you, you should get a response to it. And if you like, we prepared a fridge for you to take a picture and then to upload it. But yeah, so I can see you get some requests. It's still working, so it didn't crash until now. Yeah, that was our presentation.
All right. Fantastic. And a live demo. You get lots of points for that. Good job.
Thanks.
Yeah. Compton, did you? I was born in. It's a style thing. I understand. Yeah. Just thought you were trying to suck up. All right. Next one is sorry, it was 25. So you are 26. So you are trust through consensus. There you go. Give me 1 second. Okay, and you guys can go. Group 26.
Hi, everyone. Welcome to our presentation on trust through consensus. We explored whether using multiple LLMs at once could improve users' trust in the LLM's responses. So the idea came from a very known issue in LLMs, which are hallucinations. They make it harder for users to fully trust these models, and they add extra workload since they make users want to manually check certain things the model says. So we then wondered, could using several LLMs at once reduce these issues? If multiple models agree on something, that might increase users' confidence in that statement, and vice versa. If these models disagree, it could signal the need to verify that fact even further. So we based our research on these two questions. They guided us through our system design and also through our structure of our small use study. So to test our idea, we used Olama, which is a tool that lets us run LLMs directly on our local machines. This gave us full control over which models we wanted to use and allowed us to run several of them in parallel. Instead of starting from scratch, we extended an existing open source chat application from GitHub. We adapted its UI so that the user sees 3 responses side by side, which allowed for easy comparison. And then finally, we conducted a small user study to evaluate whether our setup actually increased trust and reduced the verification effort for the user.
All right, so let's have a look at our UI with the 3 chat columns. We left the text field at the bottom as it is, so that the users only have to type in the prompts once. On the top, we displayed the names of the models we chose for transparency. We chose them in terms of equal parameter size so that we could easily compare them afterwards. As mentioned, we conducted a user study to find out how people react to using multiple LLMs at once instead of just a single one. During the study, our participants prompted 3 questions that they could choose from a list of prompts for the LLMs and evaluated the responses afterwards. For every prompt, we asked the participants to rate their level of trust and anticipated workload to verify these answers. But before they started prompting, we needed a baseline, which you can see here on the left side. So the participants, on average, trust the responses from LLMs with a 7 on a scale from 1 to 10, and they rated the workload to verify these responses with a 4.25 out of 10. The ratings for the prompts are in the next 3 columns in this table, with the average overall on the right side. As you can see, by using 3 LLMs at once, the trust into the responses rose to a 7.46, while the estimated workload shrank to a 3.64. The results look very promising and indicate a positive outcome of the study. The research questions can clearly be answered positively. Yes, the trust into the responses from LLMs increases by using multiples at once, and the workload to verify said responses decreases overall, although of course only slightly. What we have to take these results with a grain of salt though. Analyzing them a bit further shows that there are multiple variables that need to be accounted for in future research. For example, the type of questions that the users prompt our application with needs to be calculated into the results. Asking about a topic from history is a totally different thing than asking about a legal matter, which would entail a larger amount of verification regardless of the amount of LLMs that the user chats with. A fact that we were not able to calculate properly in our small user study, and which would also have exceeded the scope. By further fine-tuning these elements for a future study, the results should get more meaningful and potentially lead down a path where trustworthiness of LLMs is increased or even established completely. Thank you very much for your attention.
Okay. So that was group 26. Number 27 is chatbots for psychological support, right?
Yes.
And so this is, oh, this is a PDF.
Yeah,
Okay.
it's a PDF.
So you can do this. I'm going to close this and we can go to full view.
Yes.
Okay, there you go.
Let me try.
Okay, group 27.
Are we?
And you can go.
Hello, everyone. We are presenting a topic that sits at the intersection of AI and mental wellness. As AI technology becomes increasingly integrated into our daily lives, we are seeing a growing trend of individuals turning to chatbots for psychological support. And in order to understand this phenomenon more deeply, that's why we chose this as our project title. And we'll be moving through 3 main parts as goals, methods, and summary. And we'll get to know our 4 goals. The first goal is to understand the motivation and the interaction patterns of individuals using chatbots for psychological support. And the second one is to compare different chatbot platforms. Specifically, we use the ChatGPT Yearkey character AI. And the third one is to investigate the potential for confirmation bias in these interactions. And lastly is to explore how prompt engineering might improve conversation quality and safety. And we conducted a survey as our first method to solve the first goal, which is to understand user behavior. As you can see from this chart, this question is aiming to understand the motivation of users. And we found out curiosity, convenience, and the lower cost are the main reasons. And the following questions are aiming to understand the interaction patterns of users. And we found out most users are using those chatbots for psychological support to express their emotions and receiving advices. And also most interactions occur weekly. And also we found out most users are quite satisfied with those psychological chatbots, but they also give some constructive suggestions, like they hope those chatbots to have more empathy or reduce their hallucinations, and also give more actionable and proactive solutions. And my colleague will present the next part.
Yeah, so as the second part, we wanted to figure out how such interactions would actually look like. So we created a scenario, which is a user being stressed at work and asking a chatbot psychologist for support. So we created a script containing 7 questions overall. 2 out of those 7 were specifically targeting confirmation bias. So asking the chatbot something like, I started eating and sleeping less, give me more tips to have more time in my everyday work. And then we tested those questions and the prompt engineered version of those on different chatbots and compared the responses based on criteria that we had defined in advance. So as a result, we have ChatGPT, we have Panda, Earkick, and C.AI. Those tools you probably don't know, those are specific psychologist tools. And the comparison showed that there were slight differences in the interaction. So Panda and C.AI responded more like in short message-like style. They had a neutral or conversational tone, and the practicality of tips was rather moderate, whereas ChatGPT answered really long monologue style, typically ChatGPT, and the tone was more professional with high practicality of tips. What's interesting here is that the confirmation bias actually didn't show up in any of the chatbots. And also the prompt engineered versions of the prompts improved only for ChatGPT and making it more interactive and short, but didn't change much for Panda and C.AI, which is probably because those tools are already specialized on being used as a psychologist.
Thank you. Okay, now to sum it up. First, we wanted to understand why people turn to chatbots for psychological support. And then using a survey, we found that users are mainly motivated by curiosity, convenience, cost, and the desire for privacy, and that they use it mostly weekly. Secondly, we compared different chatbot platforms to see how they handle emotional queries. We observed that the specialized AI psychologists, like those built into Earkick and HCIAI, tend to work well out of the box, offering conversational and empathetic replies. And thirdly, we investigated the potential for confirmation bias. And even when we tested the chatbots with unhealthy statements, none of them reinforced harmful thinking, which is a very positive result. And finally, we explored whether prompt engineering could improve response quality. It did, especially for ChatGPT. So by reframing the prompt to guide it like a real psychologist, we got answers that were shorter, more interactive, and more empathetic. And together, these findings show that with the right design and guidance, chatbots can support emotional well-being, but that thoughtful setup really matters. Thank you.
Okay, 28, understanding you. That right? I'm sorry, did I skip one?
This is 29.
We are 28 about dementia.
Oh, dementia. So I should have just stuck with what I thought. Okay, present. So team 28 about dementia. Yeah, except, yeah, sure, whatever. All right.
Ready, set, you're on.
Hello and welcome to our presentation about AI in dementia care. We did this project because of its importance, about our personal connection, and obviously the connection to human-centered AI. Our goals are here. First, Mate is going to talk about current technologies and ethical challenges. Then I'll take over and talk about caregivers' attitudes towards AI in dementia care. And then Solomon is going to talk about research findings.
Yes, so what are some current available technologies? So we have 4 main modalities: the socially assistive or companion robots to brighten patients' mood and engagement. Then we have telepresence robots so that families and clinicians can be virtually present at all times. We have AI-based cognitive tools for early detection and training so the dementia doesn't progress as fast. And then we have ambient assisted living systems and wearables for safety monitoring and just-in-time prompts. Then the goals of those technologies are basically to extend the autonomy of the patients, lift caregiver workload, and personalize support at home or in care facilities. And also the research shows that there's a small to moderate gain in mood and cognition and high user acceptance when design is simple and predictable. And then the ethical considerations. So we have autonomy and consent. The capacity fluctuates from patient to patient, so we should opt for ongoing or adaptive consent models. The privacy and surveillance topic, so minimize data collection and keep data processing local wherever we can. Dignity and deception, so avoid infantilization when designing the systems and to be transparent about what the robot is and isn't. The workforce impact, so tech should be used to free staff for relational care and not to justify job cuts. Bias and equity, models should be trained on diverse voices and languages, and we should subsidize access to avoid a digital divide. And last but not least, we have safety and reliability. So medical device standards and post-market monitoring should be applied for all technologies.
And to understand caregiver thoughts on AI, we conducted 4 interviews with caregivers who have worked with patients, dementia patients, and they were positive for the use of AI as long as the following conditions were met. First, the AI prioritizes emotional sensitivity, which means that the AI interacts in a respectful way. Then technical barriers have to be managed for both the patients and the caregivers. Caregivers said they were open to technical training. However, the training should not be by some IT expert. Caregivers should also see the benefit of reduced working hours. And the caregivers emphasize that they should be supported and not replaced by the AI. Then AI can be trusted, it should be reliable and transparent, and should be tested in a real-world setting. And last but definitely not least, the patients should accept the AI. If this is not given, then the caregivers are also not accepting the AI.
Next up, we'll talk about the case study. In the case study, we analyzed Grace, which is a robotic voice assistant that was developed inside the University of Zurich. And the system was designed to provide behavioral prompt and cognitive engagement. And the LLMs were deployed in a way with the predefined outputs, considering the vulnerability of the target. And the other thing is that the project was developed with 2 methodologies. The first one is the ethics for design value and value for sensitive designs. According to an interview that we did, one of the challenges in this project was the data privacy and the safety of the data, considering the vulnerability of the targets. And to mitigate this, they relied on an offline mode, but this determined a consequence that they have like a limited interaction with the patient. And one of the limitations of the system is the fact that it's not able to adapt to the change of the cognitive state of the patient. So in the future, what we expect is the fact that they plan to integrate personalization and contextual awareness. Of course, this is going to be without compromising the ethical safeguards. And last but not least, the goal of this project is to transform Grace into a supportive home assistant, which means they try to implement it in every house, but this is going to happen only respecting the clinical and the core human values. Thank you for your attention. Great. Thank you. Thank you very much. Thank you.
I am pleased that we had two psychological results right next to each other.
Showing correctly. Can you reload?
Which one are you?
This one? 29?
29.
Yeah, I uploaded the link to Google Slides now. Maybe it will be better.
Did I get the wrong one? This
No,
one?
it was correct one, but for some reason it was showing incorrectly with white stripe. I don't know why. That's why I reloaded it. Here's again white stripe. Okay. I don't know why.
Call it design.
Yeah.
Okay. There you go. So this is group 29. This is, like I said, we didn't anticipate having all these psychology things right next to each other, but this is another, I can do this as a psychological thing. Ready? Steady? Go!
Good morning, everyone. So today we're presenting Understanding You First, a project exploring how clarifying questions can improve AI communication. As AI become part of our daily interactions, we wanted to see how asking the right follow-up questions, not just giving the answer, can better meet user expectations. Our study looks at how this approach impacts user satisfaction and perceptions of AI intelligence. Our project had two main goals. First, to explore whether people prefer quick answers or responses that begin with clarifying questions, and how they feel about AI asking those follow-ups. Second, to see if AI can convincingly impersonate someone based on a short persona description, simulating their preferences and judgments. Our approach, we had 4 steps. First, we developed a web tool with 2 AI modes, one giving instant answers and the other asking clarifying questions. Our second step was tested with real users to gather their preferences. Our third step was to analyze the collected feedbacks to identify patterns and in user responses. And fourth, it was to run the AI simulation with fictional personas to see if it could mimic human responses and judgments based on brief descriptions. So here's a quick demo of our tool, the app we developed. So the user would enter a question and get 2 types of AI responses. Model A, which is on the left, would give a direct answer, while Model B would ask the clarifying question first. In the given example, the question is about Swiss tech trends for a move to Zürich. Model A would list trends immediately, and Model B would ask something like, are you interested in startups? Are you interested in big tech? To tailor its response to the user.
So we actually tested the app with around 15 real participants from varying backgrounds. And there was a clear preference in favor of the Model B, which is the one which asks clarifying questions or follow-up questions, with 65% voting for that one. It's interesting to see that Model A, which is like the straight up answer one, still has like a 35% preference, which we felt was quite high. Like, why would you not go for the better one? On investigating further, we found that this preference deeply depended on the nature and complexity of the query itself. We also computed a complexity score for all of the queries using simple metrics like what is the frequency of the words, what's the length of the query. And for example, for simple queries like which are short, factual, and informational, like how do I make the best water for coffee or recipe for a dish, people preferred Model A, while for more complex and personalized queries like, okay, how do I improve my mental resilience? Are genealogical tests reliable? They preferred Model B because they can, provide more context or think themselves. Through a literature review as well, we saw similar studies and investigations being conducted elsewhere. These illustrate how clarifying questions can help reduce dependence on the user input quality, and it can help achieve user input completeness, which is a big challenge. And further, some of the studies also show how the Model B or the clarifying questions makes the user think more about the problem themselves and increases confidence in the final generation. Finally, ChatGPT also does this sort of sneaky A/B testing, where they test if you prefer Model A or Model B. So it's definitely a hot topic area in AI user research.
Naturally, our respondent set was limited with our social circles, and that's why we were interested. What if we could ask ChatGPT to impersonate people out of our reach? We developed the short prompts describing certain people and asked ChatGPT to generate the questions as if they were this person. Then we asked them to assess which answers they prefer more. And we also tested it on ourselves to see if it make sense, and it surprisingly did. So in 100% of the cases, ChatGPT chose the model with clarifying questions. Here is the example of the prompt describing the personas and questions which were generated by ChatGPT. You can notice that here the questions are deeper and more personal than actually by human respondents. And we actually cannot say if ChatGPT chose model B because they had these questions or just because they preferred longer answers. So concluding all of it, we see that people definitely prefer getting clarifying questions compared to simple replies, except for the cases where they have Google search style queries, like give me the recipe or something. We also see that working with AI personas might have potential for the simple studies, but because of the black box inside, we actually cannot rely on these results. It hurts the interpretability. And we need to consider the limitations of the study with the number of people and the format and potential biases. Because we asked them to generate queries, it was not the natural day-to-day interaction.
Thank you. I like the white stripe design. Okay, we saw that. Okay. Just as a quick reminder for people, make sure you fill out the evaluation form for each team. They're filling them out for you, so you need to fill them out for them. Okay, so next will be 30. This is you, right?
Yep.
Okay. Okay, and get you going. And
Gonna start.
Are you ready? Yep. Go.
Good morning, guys. Our team spent some time on analyzing if people can tell it's an AI music or human generated music. And we tried out a few platforms and picked Sono and Marika as the final because they are the best based on our internal test. And you can see the platform. If you want to ask AI to generate a song, you just type a few words, the type and what you want, and you can write lyrics. So we created 5 folders with mixed of AI songs and human-generated songs, and we asked 20 friends to listen and see if we can tell if it's AI or human.
We briefly record their binary choices and their brief comment. And here's the result. First, you can see the mean accuracy is 68%, or about 10 or 15 clicks per person. And which means the people not guessing entirely at random, but they are also not nearly perfect. So which means they still have some blind spots on them. And as you can see, a different folder with different accuracy. The folder 2 get the lowest, and folder 5 get the highest, which can show the lyrics, the importance of the lyrics. And otherwise, with the free comments, we got 3 main cues people reported. The first is emotional nuance. The people can easily judge with the lyrics parts and the texture complexity, and the more people can like just harmonicals and vocal influence, and with the rhythmic uniformity, the mechanical and consistent rhythm will be more easily to judge, labeled with AI. And
So in summary, our study shows that a typical listener can distinguish AI-generated music from human performances with moderate accuracy, 68%. But this ability varies notably depending on musical context. recognition was strongest when lyrical content differed between AI and human versions, particularly in Fold 5, where participations achieved 95% accuracy. In contrast, instrumental electronic tracks in Fold 2 were much harder to judge, with accuracy dropping to 66%. So these results suggest that listeners rely heavily on emotional expressiveness, textual richness, and lyrical content as cues for authenticity. When such cues are minimized, especially in purely instrumental or highly uniform tracks, determination becomes more difficult. Performance improves when lyrical content and emotional cues are present. That's it.
Great, thank you. All right. Music is near and dear to my heart. Okay, we have two more presentations. And this is now group. Somebody keeps opening up my tabs. So this is your group 31 now, right? So fair frame. This is you, yeah? Okay. Okay. Maybe get over here. I don't want to miss a word of this. Group 31, you're on.
Hi, this is Fairframe, and my name is Hyung-Suk, and this is Max. And we learned a lot about AI, and I think here are already very aware of that the generative AI contain a bias. And we went through how the current AIs are using to debias this bias and how to give user control. First, is there a bias in Gen AI? Yes, the Bloomberg studied that creating faces on the certain occupations and liability to their skin colors and the genders. And the results show that the high occupation jobs have like lighter skin color, and the male occupations, male proportion is high, and the low paid jobs contains the opposites. And how do current AI companies to try to debias these biases? The first is giving the system prompt to debias the prompts, like applying the country or cultural specific to the prompts, or just assign a value to how race and ethnicity are to be distributed. And the second option is to modify the training. They filter out the harmful or like inappropriate data from their training data, and they filter them out, and they reweight to the match to their ideal proportion in their training data, like gender or ethnicity. But this doesn't always work. Like in this article, they debias too much, so they create an inaccurate figures like Native American Vikings, or like impossible ethnicity figures in like World War II German soldiers. And so we went to another approach.
Yeah, so now we want to see if we can use human-centered design and to mitigate such biases by making users aware of the biases and giving them some control over the biases. We created a prototype which includes like a normal text box for the prompting, and then also a panel for fairness and bias control. Then we did a survey. We gave participants a task to create an image, once without such a panel, just a text box, and once with our prototype. And then we compared the two, but more to that later. This is a small demo of how such a task would be fulfilled. It's not the best underlying model, but it kind of works in principle. So he put the gender slider there. So it's not only white male people, but also female. And also the increased demographic diversity toggle works second time, actually. Yeah, so you can see it kind of works in principle. And then we compared this approach with one without the panel. So what did we find? Like, first of all, not any of the participants really thought about fairness when no such panel when they're not exposed to such a panel. However, when they see it, they think about it. They see the panel, they think, yeah, why not just use it? Especially when the diversity is not part of their main goal. Another thing is that the image generator actually produced a more ethically diverse output. As said, the model is not that good, so the results are not perfect, but we can see some kind of trend that they saw the panel, they used it, and they got a more diverse output in the end. So what does that tell us? Yeah, for one, like I said, people don't think about fairness when they use just the normal UI for generative AI. They won't go and think about additional prompts and say like it should be diverse and so on. They just take the output as is. And we also saw that such interface design where we expose them to biases can empower fairness. So as long as biased models exist, such modifications can be kind of a temporary fix, empowering fairness not just through algorithms but also through design and UX. So on a different level. However, realistically, we don't think such panels will be adopted by the most popular tools. So in the end, we are back at the root problem. So we need to have unbiased models in the end, which we think should be the focus on regarding the research in this field. Yeah, thanks for your attention.
And our very last presentation for today is called correct, absolutely right. Full screen. This is yours.
Thank you so much.
So group 32, wait. Okay. Are we ready for the last push? Go.
So welcome everyone. Today we will discuss our project of students from different faculties use generative AI in their coursework with my colleagues Elif Deniz and Gökberk. Yeah. So before start, I want to talk about our main objective. So we know that generative AI tools are becoming more common in education sector, and we are seeing a lot of implementations of it, for example, like Camingo, as we saw from the lectures. But I think despite the tools are very common, we have few knowledge about how students from different faculties embrace these tools. So for understanding better how students utilize generative AI on different faculties, we created a short survey. So let's talk about our survey. This is a snapshot from our survey. So basically, we asked 20 people from 5 different faculties, and they filled this survey anonymously. So questions includes their major, how often they are using generative AI, and what purpose, which coursework they're using it. And also, we curious about which models do they prefer most, because we believe that except ChatGPT, those and other tools are not very common in other faculties, not familiar with those students. So also we asked if they find useful those generative AI tools and how much they trust generative AI. So my colleague Gökberk will talk about the results.
Hi, everyone. So in the first chart, we talk about platform preferences. And this is the easy one because most students prefer ChatGPT as their main Gen AI tool. And because it's easy to use, as people, got used to it as it was the firstly launched Gen AI platform. The second part is about Gen AI preferences, but so here we see that natural sciences students show less diversity in their Gen AI tool preference. And additionally, we see that Copilot is only used by engineering students. So it's probably because their tasks mostly focus on coding. And in the third chart, we have faculty-specific use cases. So here we have four main use cases. So coding help, writing essays, idea generation, and concept explanation. Writing essays is about structured arguments, and idea generation is about creativity. And concept explanation is the part that you ask questions to better understand lecture content or any kind of academic topic. So here, what draws attention is that creativity-focused content is mostly used by the fine arts students, and we see that concept explanation almost equally distributed among different departments. In the fourth, we talk about frequency of use by faculty. So for this part of this survey and the next parts, we use a scale from 1 to 5, and 1 is never, and 5 is very often. And it is interesting here to see that the lowest average is 3.0. So it means that people or students are frequently using these platforms. And the differences on the bars in the chart may show the variation in workload type or how well current GenAI tools support these different needs. And to investigate the last point better, we asked 2 different questions. And they are about usefulness and trust. So in this chart, we may see a positive correlation between the trust and the usefulness. So it means that students tend to rely more on the GenAI tools as the usefulness of that tool increases. And by looking at the chart, we can say that students who work with more scientific and logic-based content relatively have higher trust in the GenAI tools. And I want to state that this was a short survey with 5 to 6 questions, and there were only 20 participants, so it may also not be reflecting the reality as well.
Thank you. So to sum up, as we see, GenAI adoption varies significantly by discipline, reflecting diverse needs. So also we have some recommendations about improving the GenAI tools on education. The first one is AI tools should allow users to choose specific context, like creating an image or writing or coding to provide better, more useful outputs. And our last recommendation is educators should create clearer guidelines about GenAI usage to support responsible and ethical integration into coursework. Thank you for your listening.
Plus 1 second. Nice.
So that's the official end of, how do I get this? The official end here. And I want to thank everybody for coming to the class. I appreciate you all showing up here, which is great. I hope you enjoy the cookies, enjoyed the class in general. I certainly did. As I've told you at the very, very beginning, this class changes every single time I teach it. As you found out from the AI news thing, which we just started, AI and HCIAI is changing week by week by week. So I'm planning on coming back for fall of next year, and you could take the class again, and it will be 75% different. I don't know what your faculty will say about that, but that's not my problem. So the fun part for me is that I get to see all of your presentations, and I get to see the stuff that I'm studying, the stuff that I do, filtered through your lenses. So I really, really appreciate it. I appreciate all your work and all your effort. The next step is that I will take all of the evaluations, pull them all together, and send them out to each of you so you can read what your peers wrote about your work. Okay? Chat, Izia, and I have been doing some evaluation, and we will take that, and then that will I'll massage that and turn it into your final score. I will then send out emails to all of you saying what the final score was, and I will post the videos. I think there was a little gap in today's video, so I think the second half of the first group may not have a great video. That's not my problem. That's Google Meet's problem. But anyway, I also want to thank Izia, and I want to thank Chat for being such great helps in making all this work. Thank you. Not the least of which is Chat fed me some great high caffeine tea today, so I appreciate that. All right. It's been a pleasure having you all here. I hope to see you all again next year when I'm back. Take care.